We have learned several rules for finding derivatives, and now we're going to learn another one. The rule that we're going to learn is the chain rule. And before we talk about how to do the chain rule, we want to talk about what type of problems need the chain rule. Let's look at this example of a manufacturing procedure. The process of making chocolate is very involved and includes lots of steps. And in large factories, the process is automated. There's many components, an assembly line, and each station, a single component of the process is completed before it's sent to the next station. So here's the steps. First, we're going to roast and crush the beans. Then we're going to mix in other dry ingredients. This should say tempering the chocolate, which just means that it's heated and smoothed out, and then packaging. Let's look at a simplified illustration of what's going on. We start with the cocoa beans, then they are roasted and crushed. They're turned into a paste, then they're turned into chocolate, and then they're done and ready to be packaged. So what does this have to do with calculus? Well, the important thing about this is that the output of one step becomes the input of the next step. So beans go in, then out comes something that we're roasting and crushing. Then that goes into the next step, and then it's turned into a paste. And then the next step is turned into chocolate. The next question says, does an assembly line worker on step 3 ever interact with raw beans? And the answer is no. So now let's use this idea of putting something into a step and then getting something out and then doing another step. Let's look at this function. F of x equals the quantity 5x squared plus 7 all cubed. The first question says, what is the independent variable, or we could also call it the raw material of this function? Well, this is going to be x. We're putting x into the function. Then what happens when we evaluate this function at x equals, I'm going to change this to 2. Since we're dealing with a cubed value, it gets very big very quickly. So what happens first? Well, first we're going to square the 2. Then the next, so we are going to look at the function f of x equals 3x squared plus 7, and then that whole quantity will be cubed. The first question says, what is the independent variable or the raw material that we're going to put into this function? The raw material is just going to be this x. Then it says, what is going to happen when we evaluate it at x equals 2? What happens first? Following the order of operations, we're going to square the 2. Then we'll multiply by 3. Then add 7. So this will be 2 squared times 3 plus 7. This will be 19. Question 4b says, what's the final step? Well, I need to cube whatever was in the parentheses. So I'm going to take the 3x squared plus 7. That's going to be 19. And then I'm going to take that value of 19 and I'm going to cube it. This will be 6,859. Now, the next question is very interesting. It says, does the cubed function ever interact with x equals 2 directly? The answer is no, because the input is not x. It is 3x squared plus 7. So I'm doing a few things to x, and then once I figure that all out, then I'm going to cube it. This function here is called a composite function. And what happens with the composite function is we have our x, and then the x will get put into our function g of x, And whatever we get out for g of x, that's what we're going to put in for f of x. Let's go ahead and write down everything about the composite function, and then we'll talk about the chain rule. So we have our composite function. That's going to be y equals f. And then instead of having an x inside the f, we will have a g of x. The f is going to be the outside function, and the g will be the inside function. So I have my x, and whatever my x is, I will put it inside the g of x, and then everything that's g of x will go inside the f of x. So now we've explained what a composite function is. To find the derivative, we need to use the chain rule. So we have our function y equals f of g of x. To find the derivative of this function, we're going to find the derivative of the inside function times the derivative of the outside function. This is going to be the derivative of the inside, and this will be the derivative of the outside function with respect to f's input. Now, since these two terms are being multiplied, you can do them in either order. The next two examples I'm going to show you, I do the derivative of the outside first, then multiply by the derivative of the inside. It doesn't matter which order you do it in because we're multiplying. The choice is up to you how you want to do it. I am leaning a little more towards doing the derivative of the inside first, because that way it doesn't get forgotten. When we're dealing with derivatives that have lots of parts, it's very easy to forget to also multiply by the derivative of the inside. So let's do a couple examples. This 5u cubed minus 4u, that will be the inside function. So the way I'm going to do it is I'm going to take the derivative of this outside function first. This is something all squared. If I had x squared, the derivative would be 2x. So the same thing here. G prime of u is going to be 2 times, but instead of times x, it'll be times this inside function. So 5u cubed minus 4u. The inside function is unchanged. Then I will multiply this times the derivative of the inside. So this piece here. So times the derivative of 5u cubed is going to be 5 times 3u squared minus the derivative of 4u is just 4. If you would like, you can multiply this all out and combine like terms. I'm just going to leave it this way since the directions don't say to simplify or not simplify. I'm just going to leave it like that. Let's do another example. Now with this problem, we can do quotient rule, but we would have to do the chain rule and the quotient rule together. And right now, let's just learn the chain rule and get familiar with that, and then we can start applying additional rules. Now, I am going to rewrite this as 5 times the quantity 4 minus x cubed, all raised to the negative 1/2. All I did was rewrite this denominator. So I haven't done anything, we haven't taken any derivatives, I've just rewritten it. So now this 4 minus x cubed, that becomes our inside function. All right, so g prime of x is going to be 5. That's just a constant, and the constant gets multiplied by everything. Then I want to do the derivative of the outside. So think about this as something raised to the negative 1/2. Well, to find the derivative of whatever this thing in the middle is raised to the negative 1/2, I'm going to multiply by negative 1/2 times whatever that something is,
and then I'm going to subtract 1 from the exponent. And in this case, since we're dealing with fractions, we have to find common denominator, so this will be minus 3/2. And then the inside remains unchanged. Then I need to multiply by the derivative of the inside. Well, the derivative of 4 is 0. Then I have a negative, and then the derivative of x cubed, which is 3x squared. So I'm going to leave it just like that.